Right. Okay. All right, so I have the streaming already enabled with audio, so everything is ready to go. So what we'll do at this point is kind of to mix and match stuff that we have not done before. So we'll start with parameters. In other words, we might take a short, very short break from types and records and stuff like that. So we'll focus on parameters today. So the question is, what if you have a parameter that is passed by value already, and then you pass it by value again to another subroutine? We have dealt with that one already, okay? Because all the recursion that we have done up to this point pass a pass by value parameter to something else. So that should not be a big surprise. The second one is you have a parameter that's passed by value to you as a subroutine, and then you pass it by reference to another subroutine. Then we have pass by reference to you, and then you pass it by value to somebody else. And then we have pass by reference to you, and then you pass it by reference again to somebody else. So there are four possible combinations, and we'll go ahead and explore all four possibilities in today's lecture. Yes. So that's going to be on the final, because all of these things can happen in the C program. So it is kind of important to find out what happens when you have these combinations. So for the most part, today's lecture does not really have any written notes on it, except for what we already understand about passing by reference and also passing by value. But the spreadsheet is important. Okay, so what I'm going to do today on the spreadsheet, is going to be kind of the key. And if someone reminds me, I can upload the spreadsheet again, onto Canvas, so you guys can have the spreadsheet itself. The lecture is already being recorded, so if you need to refer back to the description of the concept, you can watch the video again. So let's go ahead and get started with this particular lecture. So we have define sub, we'll call this S1, okay? And we'll start with passing by value and then passing by value, okay? So this is V1, and this is what we do to V1. V1 gets V1 plus 1, okay? And define sub, and then we have define sub V2, S2 for subroutine 2. This time we also pass by value V2. Well, it can be the same name, it should not matter because they are different parameters of different subroutines. So it really should not matter. So V2 is V2 times V2 and define sub. And then we have main, define sub main. And in main we have a local variable, we'll call this n, and starts with the value of, doesn't really matter, let's say 5. And then we invoke sub, okay, I forgot one thing here, because sub 2 is going to call sub 1. So we'll go ahead and insert one more row here, and then we say invoke sub 1, S1, and we're going to use V2 to specify V1. There we go. And then in main, we're going to invoke S2. And the way we invoke S2 is to use n to specify V2 and define sub, that's for main. And then we say invoke main. And that's it. That's the whole program. I'm going to fix some of the indentations, because this makes it a little bit easier to read. Where is my indentation tool? Right here. Okay. And this one should be okay because of all the subroutines that we have studied up to this point, the recursive ones, this is what we have been doing. Okay, we're passing parameters that are passed by value to a subroutine and then pass it by value again to another subroutine. All right, so there we go. And we'll zoom in just a little bit. Okay, so this makes the code easier to read. And then we open a new window for the trace. Okay. All right. So this is the trace. We don't need comments, simply because there are no conditions to evaluate in this particular program. So we start with line number, and we'll zoom in twice like that. The precondition has nothing to say because we do not have global variables. Okay, so you might have noticed that I have kind of stepped away from using global variables, and there's a good reason for it. Okay, there should be very little need to use global variables as far as your homework assignments are concerned. That's not only for this class, okay? That's also including CISP 360, 400, and 430. Those are the three main programming classes that many of you will be taking. Some of you only need to take CISP 360, and that's it, because you are not in a computer science or computer engineering degree. Others will probably have to take 400 and 430. So anyway, try to avoid the use of global variables because the problem with a global variable is it can be changed by any subroutine. You cannot just look at how a subroutine is called to figure out that, oh, I can see this particular subroutine may potentially change this thing over here. Because there's nothing you can tell from just calling the subroutine that it can change a global variable. So that's why it's not a good idea. Okay. So we start execution on line 15. Line 15 doesn't do a whole lot. It is just going to invoke main. So we need to reserve a return line number to remember that when we're done with main, it is time to get out of the entire pseudocode. And main also has a local variable called n. And as a local variable, it starts with an unknown value. So that's how we set up columns B and C for invoking main on line 15. Then we go into main, starting on line 12, and gets a value of 5. And then we get on to line 13, whoops, right here. And line 13 is invoking S2. So we need to reserve another column for return line number. And this time when we get back, we have to get to line 14. And we also have to reserve another column for parameter V2. Now, because V2 is a parameter, it always starts with a particular value that the invoke statement is supplying. So since on line 13, I'm using n to specify a pass-by value parameter, that means V2 is going to be what? Should I say AKA column C, or should I say 5? We should say 5 because it is passed by value. So we look at the value and we copy the value when we are passing by value. Okay, so now we get into subroutine S2 starting on line 7. Line 7 says, okay, we are multiplying V2 by V2. Okay, V2 has a value of 5. 5 times 5 is 25. So we store the 25 back into V2. So here's the question. Well, but V2 is a parameter. Can we store a value back into a parameter? The answer is yes. Okay, a pass-by value parameter, for the most part, behaves just like a local variable. You can update it inside the subroutine. Okay, now in C and C++, there are you can place a restriction and say that you cannot change the value of a parameter. Okay, using the keyword called const, C-O-N-S-T, which stands for constant. We're not going to talk about that concept here. So for this class, we are assuming that you can change the value of a pass-by value parameter. And the way you do it is simply change the pass-by value parameter as if it is a local variable. Okay, so then what do? We go to line 8. Line 8 says we have to invoke S1. So that means we need another column for return line number. And this time when we do come back, we have to get to line 9. Okay, not too complicated. And because S1 also has a parameter called V1, we need to reserve another column for V1. What do we use to pass to V1? We're using V2 to pass to V1. Now it is also passed by value. Now how do we know whether it's passed by value or passed by reference? It is the parameter itself that tells us whether it's passed by value or passed by reference. So in this case, V1 on line 2 clearly states that it is passed by value. So we want to figure out the value that we are using to specify V1, and it is the value that we write down in column G. So in this case, v2 has a value of 25, and so we just copy the value of 25, to become the beginning value of v1. So when we get to line 3, we are adding 1 to v1, so v1 goes from 25 to 26, and then when we get to line 4, we deallocate all the columns for this particular invocation. So that would include column F and column G. But before we do the deallocation, we look up the return line number to remember that we have to get back onto line 9 after this. So now we can go ahead and deallocate these two columns. So we go to Format, Text, and then strike through. And you can see the result of 26 is gone, okay? Because the column that stores the value of 26 is no longer in use. So as a result, that value is no longer existing, okay? When we get back onto line 9, which is here, it is the end of the subroutine S2. So we're going to do exactly the same thing, which means we are deallocating column D and E in this case. But before we deallocate, we have to remember to continue execution on line 14. So we just copy line 14 over here, and then we do the same thing and mark these two columns as deallocated. Now that we get back onto line 14, which is the end of the main subroutine, we're going to do the same thing, okay? These two columns are no longer in use, okay? And we are supposed to continue execution at post. And so once we mark it up, then we're all done. Do we have any questions about this particular trace? Yes?
What would this be used for? Because it did absolutely nothing.
It does absolutely nothing. That is correct. The only purpose of this particular program is to illustrate what do you do when you have a pass by value from the perspective of subroutine S2, and you're passing that parameter by value again to another subroutine. That's all it is supposed to do, is to illustrate the mechanism of passing by value.
But what would you use that mechanism for?
Passing by value?
Yeah, passing by value twice.
Most of the time, most parameters are going to be passed by value. Because you're only supplying information for the subroutine to do, and then usually the subroutine that does something will return a value back to the caller using the return statement. But in this case, I'm not complicating it because it's not the main point of the discussion. So passing by value is quote unquote the default because it's the safest way to do it. Because the subroutine has no way to modify something that does not belong to the subroutine. So you don't have to worry about the callers, local variables or whatnot getting modified by the subroutine unnecessarily. So it's a safe way to pass, parameters, to supply information for a subroutine to get the job done. Okay? All right. Any other questions about this particular trace? Yep.
Line 9, column E should be V2.
Column, line. Okay, are we talking about the trace or the program? The trace on row 13? Oh, okay, V2 instead of V1. You're right. So this one should be V2. Okay, thank you. Are we good so far? Okay. All right. So we're going to add a new program. Okay, it's going to look almost exactly the same as this one with a minor difference. So the only minor difference is we're going to pass by reference to S1 here. So this is the only difference. Now in this class, because of the way I use the notation, when you pass something by reference, you cannot use a right arrow. You have to use a double-sided arrow in this case. It really is just a graphical way to emphasize that this is passed by reference. Whatever happens to V1 happens to V2, but V2 technically belongs to S2. Okay, so it's in a real programming language, you don't do that. Okay, in a real programming language, you don't even name the parameter that you're passing to. It is all done by position. But in this class, we try to make it very clear that we are passing something by reference and what is the name of the parameter that we are passing it to. Okay, so this is the only modification to this program. And then we'll go ahead and track down what this program is going to do. So once again, just line number precondition has nothing to say. There are no global variables in this case. So we start with line 15 again. Return line number is post. We have a local variable n starting with an unknown value. Okay, nothing exciting. Everything is kind of the same as before. And then we get into the subroutine S2 on line 7. We are multiplying. Oh, okay, take it back. On line 7. Oh, I forgot something, didn't I? I forgot something here. Okay, insert row above. Okay, because on line. Nope. Okay. It's inside main that I forgot something. Inside main, we have line 12. Okay, there we go. So on line 12, we are assigning a value of 5 into n, just like before. And then on line 13, we call the subroutine S2. So we need to set up return line number and also one column for parameter v2. It is still passed by value, so that means v2 would still be just the value of 5. Okay, and the return line number is going to be line 14. And so this part has not changed. So far, nothing has changed from the previous trace. Then we get into the subroutine S2, starting on line 7. It says V2 gets V2 times V2. Okay, so V2 gets 25. Now it gets a little bit different, because on line 8, when we invoke subroutine S1, we are passing V2 to V1 by reference. So that means when we set up the 2 additional columns, the return line number would still be the same as before, because we still have to return to line 9 to continue execution. But the way we set up V1 as a parameter, because it is passed by reference, now what we need to write down in this cell is to say, where do we find the thing that was used to pass to this particular parameter? It would be column reference to column E. Yep. So reference to column E. So the idea of passing by reference is the parameter gives you a way to get back to the original item. Okay, that's the whole point of passing by reference. Okay, so this is starting to be different from the previous trace, just a little bit. When we get into the subroutine S1 on line 3, the right-hand side says V1 plus 1. We look up V1. V1 is a reference to column E. You cannot just add 1 to the reference. Okay, you can only add 1 to a value. The value is in column E. Column E says it has a value of 25. So V1 is 25. Okay, it evaluates to 25. 25 plus 1 is 26. So we store that back into V1, which is a reference to column E. So this is the important part. When you update a pass by reference parameter, you update the referred to the column that the parameter refers to. So in this case, column E is the one that is updated to 26. And then we get to line 4, the end of the subroutine. So we now deallocate these 2 columns. And then we remember that we have to get to line 9. Okay, so we just go to format text, strike through, oops, format text, strike through, there we go. So now we get back onto line 9. So when we,
So on row 11?
Row 11,
Yeah. V2 gets updated, 26.
V2 is the one that got updated. So, okay, so this is a very good question, okay? On row 11, okay, how should we call this? Did we update V2 or did we update column E? Or did we update V1?
Basically, based to the codes, we should update V1.
Yes, so we use V1 to give us an idea of what we should be updating. Because when V1 itself is not a value, it is a reference to somebody else. When you update V1, you're updating what it is referring to and not the reference itself. It is, and that's why we have a two-way arrow. Is that okay?
Yeah.
Okay. But I still want to kind of point out, what is this update here? In other words, how should we call this? Did we update V1? Did we update V2? Or did we update column E? The answer is all of the above. Okay, it is all of the above. It depends on your perspective. It depends on where are from whose perspective are you trying to look at this. If you're looking at this from the perspective of S1, the subroutine S1, you updated as V1 as a parameter. That's what you did. Okay. If you look at this from the perspective of S2 as a subroutine, we just let somebody else to update the parameter V2. But when you look at the actual mechanism, then it is column E that got updated. So we call this aliasing, which means the same column has got multiple names. It is known as V2 as a pass by value parameter from the perspective of S2, but it is also known as V1 from the perspective of S1, okay, which is a pass by reference parameter. So it has multiple names. It has aliases. Is that okay? All right? Yep.
So I just got a quick question about perspective. So
Uh-huh.
in the perspective of S1,
Mm-hmm.
the local variable n doesn't exist, right?
From the perspective of S1, n is out of scope. We call it out of scope because n is a local variable within main, which means the only place you can refer to this n is from line 11 to line 13.
So how would you pass it by reference to another subroutine?
You mean passing local variable n? You have to have a chain of passing by reference in order to get it down to whatever level of subroutine you want to get it to. So eventually we will have an example to do that. So right now we are not, because remember we have a table of 4 possible combinations. We have passing by value, passing by value, passing by value, passing by reference, pass by reference, passing by value, passing by reference, and passing by reference. So we are only on the second one at this point. Okay. All right. So after this point, so you can also see when we deallocate column F and column G, the effect of subroutine S1 is still here. Because we didn't change something that was deallocated. We just deallocated a way to find that column. But that column, the column E itself, is still in use at this point. So when we get to line 9 and define sub, this is when we deallocate these 2 columns. Okay. And at this point, we have lost the effect of that pass by reference effect. We have lost 26 basically at this point. And then we continue execution at line 14. And at line 14, you can see the n is still the same as before. Okay, nobody has changed n at all except for the initialization. So now we also deallocate these 2 columns. And then we continue execution at post, and that's the end of this particular sample program. So are we okay with this one? Does everybody understand how this particular sample program is different from the first one? Okay, so this one is not too bad. Okay, then the next thing we're going to do is to change V2 so that it's passed by reference, and then change V1 back to passing by value. Okay. So I'm adding additional sheets. So this way, when you get the spreadsheet and you want to study, you get all 4 cases. Okay. All right. So now we change this one to pass by value, and then we change this one to pass by reference. So this one is just to illustrate what if you have a parameter that is passed by reference to you, but you have to pass it by value to somebody else. Okay, so it's illustrating a slightly different concept. But because of the change of the passing by value versus passing by reference, we also have to change the arrows. Because V1 is now passed by value, which means we only need a right arrow to indicate how the parameter is passed. But n is now passed by reference to V2, so now we have to change that one to a double-sided arrow. Now, once again, this is only for this class when we write code in pseudocode, because I just want to emphasize, that this is, whether something is passed by reference or passed by value. In regular C, we do not use these, symbols at all. So, whether something is passed by reference or passed by value depends on how the subroutine is defined. And you cannot really tell from the invocation itself whether something is passed by reference or passed by value. Is that okay? Does everybody understand what I just said? Okay. All right, so this is the new code, and we're going to trace it. Here we go. All right, so we got line number again. Nothing to say about precondition. On line 15, we've invoked main. So we got return line number and local variable n. Okay, so not really a whole lot of changes. Then we continue execution on line 12, n gets a value of 5. No change at this point. We get to line 13. Now we start to have a little bit of change. So when we set up the columns of S2, we have return line number, and we have to go back to line 14. No big change here. But V2 is now passed by reference, which means V2 is now a reference to column what? C. Column C. Very good. So this is how we set up all the columns when we get into subroutine S2. So when we get into subroutine S2, the first thing we do is computing the square and then put it back into V2. So on line 7, we go to V2 and say, okay, what is V2? Don't look at me, look at column C. Column C says I have a value of 5. 5 times 5 is 25. But when we store the 25, we're storing it to V2. So we look up V2 again and say, well, where should I store the 25? Don't store it here, okay? Column E is not supposed to be updated. Store this value to whatever I'm referring to. So that would be column C. So column C is now updated to 25. Are we good so far? Okay. And then we move on to line 8. We are invoking S1. So we have return line number to line 9. Okay, easy peasy. And then we have V1. So now the question is, what are we going to pass to V1? Are we going to pass V2, the whole thing, to V1, which means it is a reference to column C? Or do we pass the value the V2 is referring to V1? The value, very good. Okay, so we go to V2 and say, okay, give me a value so I can pass to V1. And V2 says, don't ask me, look at column C. Column C says we have a value of 25. So it is the value of 25 that we are passing to V1. Is that okay? Because I think this is the first time we have seen something like this, where we pass a parameter that is passed by reference to a subroutine, and then we pass it again by value to another subroutine. So let me make sure that nobody has a question about this process. Are we okay? So yeah, go ahead. We do not use return info at all because none of the subroutine has a return statement. We only use return info when a subroutine has a return value. But since none of the subroutine has a return value, we don't have to use return info. If you want to, you can use return info, except in this case, the return info, for instance, in this case, is line 14 and then the whole thing, because that's where you're going back to. We're not going back to the same line as in the case when we have a subroutine that returns a value. So are we okay so far? Yes? Okay. So after this, after we set up all the columns, we continue execution in subroutine S1, starting on line 3, and then we add one to V1. We look up V1. V1 is not a reference to anything else, so we update V1 itself to 26. Is that okay? All right? Okay. So now we get back to, we go to line 4. Line 4 says, okay, we're all done here. We deallocate both of these columns. Okay, we go to format, strike out, and according to this, we are supposed to continue execution on line 9. And when we get to line 9, we now deallocate these two. Okay. And then we look up the return line number. It says we have to continue execution on line 14. And you can see the 25 is still here. The 25, when we made the change from 5 to 25 on row 8 of the trace, that effect stays all the way until this point. So when we get to line 14, which is the end of the main subroutine, now we have to deallocate everything for main. And so we get rid of these two. Okay, format, text, strike through. And then we go to post, and we are done. Are we good with this? Yes? Okay. And now we are down to the last of the 4 combinations, which is something that is passed by reference to a subroutine is once again passed by reference to another subroutine. So we want to find out, well, in that case, are we passing the original reference along, or are we passing a reference of a reference along? Okay, so we'll go take a look at that one. So at the end of all of this, okay, if you guys are interested, I can give you the C equivalent code of these particular programs. And then I can go through the debugger and show you, from whose perspective what is changed. Okay, so if you guys are interested, it's a little bit out of the scope of this class, but it will help connect to the next class that you're going to take. All right, so we have this one, and then this time it is both passed by reference. Okay. Like that, because both parameters are passed by reference this time, so all of the right arrows become right double-sided arrows. So this one is also changed to double-sided. There we go. All right, so I think we got everything done. Okay, now we can go to the trace window, and we have line number. Precondition, nothing. On line 15, we invoke main. We have return line number of post and local variable n that starts with an unknown value. Then we get into main, going to line 12, n has a value of 5. There we go. Okay, 5, there we go. And then we get to line 13. So this is kind of like a combination of the previous 2 programs. When we call S1, we have return line number to line 14. Okay, so that part is not very exciting. But on column E, we're going to have to say, V1 as a parameter is passed by reference. So what should I write here? You guys should remember this from a previous one. AKA column C, reference to column C. So both are good. Okay, reference to column C. Okay. And then we continue execution in S2. Yep, in S1. It's V2, not V1. There we go. So now we go to line 7. Line 7 says compute the square and put it back into V2. So when we look up the value of V2, V2 says, don't look at me, I don't have a value, but I can tell you who has a value. Column C has a value. Yep, column C has a value of 5. 5 times 5 is 25. Then we say, let's store that 25 back into V2. We look at V2. V2 says, don't store over here. I can tell you where you're supposed to store that value. You're supposed to store the value in column C. So we put 25 in column C. So column C is the one that is updated to 25. Okay? We've seen this already. It's not new. Then we get to line 8. Line 8 is calling S1. So we set up the columns again. So we have return line number to line 9. That's not too exciting. And then we have parameter V1. So this is the tricky part, okay? Because I am using V2, which was passed by reference to S2 already, and I'm now passing it along by reference to V1 of S1. So now the question is, what should I put into this particular cell, which is G10? So so we have a few choices here, right? Two logical choices. So we can say this is a reference to a reference. So we say this is a reference to column E, which in return is a reference to column C. Okay, that's kind of one way to do it. Or we can just say that, hey, since the objective is so that subroutine S1 can get to the column that I'm supposed to have access to so I can change it, why don't we just say column C, right? A reference to column C. And that turns out to be the correct interpretation. So when you pass a pass by reference parameter along to another pass by reference parameter, you're just passing the reference along. You're just telling, since you know where to find something, you're just passing that instruction along so that another subroutine also knows where to or how to find something. Are we doing okay so far with this? Yes? Okay. So this is important because that by the time we get into S1 on line 3, when we add one, we're adding one to column C. Column C is once again changed from 25 now to 26. Okay, and we're all done here. On line 4, we are deallocating column F and G. Deallocating these two columns doesn't do anything to column C. Column C already has a value of 26 and it will stay there until main itself returns. Okay, so we'll do all the usual markup. Continue execution based on this 9. We're going to continue on line 9 here. And then we deallocate these two columns. And then from here, we know that we have to continue onto line 14. On line 14, it is also deallocating a whole bunch of stuff, which would be these two. And because of this post, we continue execution here, which means we're all done. So are we okay with these 4 variations of passing parameters in different combinations? So what you need to remember is the purpose of passing by value versus passing by reference. When something is passed by value, all you're passing along is the value of the expression that you're passing along. When it's passed by reference, it means the subroutine needs to find whatever item that you want the subroutine to have access to. So you need to pass along, okay, what column are you supposed to refer to? So that is the key. Are we okay now? Do we have any questions about how you can combine pass by value versus pass by reference? No questions? Does anyone want to see the C equivalent programs and how I can kind of show you what it looks like in the C program? Okay, very good. So since there are a few people saying yes, I think it's good to kind of show this in C. This is out of the scope of this class, okay? This is in, but the C code is out of the scope, okay? But it is still relevant because all of you, okay, I think practically every single one of you need to go to the C class, right? So that means, the C sample program is going to be actually helpful. All right, so we'll go to, I just got past the one that I want to stop at. Okay, this is the one. And we'll say val first, okay? So this is passing by value and then pass by value again, okay? And we will, I'll put this side by side, okay? I will even put this side by side. You can see the C code versus the pseudocode here. All right, so in C, we say, okay, come on, void S1, and it has a value v1, integer v1 as an argument. And then what it's going to do is to say v1 gets v1 plus 1. Okay? Is that okay? I'm not going to teach the syntax of C programming, but is it kind of clear enough how pseudocode corresponds to C code? Are there any questions about the C code? Okay, yeah, go ahead.
So how do we know that the value that we have over there is set by value?
Because, okay, I'll show you. Because the only way you can tell whether a parameter is passed by reference or not is if it's passed by reference, there's an ampersand in front of the name of the variable. If it is without an ampersand, it is passed by value. So in C and C++, it is they don't spell things out using words a whole lot. So that means it's a little bit harder to understand because it uses a lot of symbols. If you don't remember the meaning of the symbol like ampersand or asterisk and stuff like that, then you have to go like, oh man, what does this mean? Because it doesn't use words to describe those things. Okay. Yep.
So how much there is similarity between Java and C?
Java and C are very similar. I'm not a linguist, so I don't understand a lot of foreign languages. So but from what have been exposed to, I think it's kind of like between Spanish and Portuguese. So you can still kind of make out even if you don't know Java, but you know C and C++. If you read a Java program, you can understand like 80-90% of it just fine, and vice versa as well. So if you learn Java first and you have no exposure to C and C++, and you start to read some C code, you can probably get in that case about 60 to 70% because there are some features of C and C++ that are really unique to C and C++, so it doesn't go the other way around as 80% or so. Question?
I just said something to follow you.
Oh, okay. All right. I also want to kind of emphasize this little slide here. No food or drink. I think it has to do with the use of carpet in this classroom. They don't want to have to clean it up too often. All right, so now we get to S2. So in S2 we have a parameter called v2, and the first thing we do is v2 gets v2 times v2, and then we call S1, and when we call S1 we use v2 as the parameter. Okay, this is how we call subroutines in C, and you can see there's a whole lot less typing, right? Because the invocation, what line 8 looks like here, which is a whole lot of words, we're invoking the subroutine S1, and then we're using v2 to pass to parameter v1. In C, it's like super short, okay? You don't even say the word invoke, okay? Every time you have an identifier and then you have parentheses, right after that, that is an invocation. That's how it knows. That's how the C compiler can tell, oh, you're invoking a subroutine. And what about v2? v2, it's all done by position. So the first argument, the first thing you specify in the invocation goes to the first parameter. The second thing goes to the second parameter if there are additional parameters. So C code is far more concise compared to pseudocode that we talk about in this class. But that also makes it kind of harder to understand in some cases, because if you have 3 parameters, then you have to remember the positioning of the parameters because you don't refer to the names of the parameters. Is that okay? All right? Yep.
What does void mean?
Void means it doesn't return anything. It means S1 and S2 do not return values. Do not expect any values being returned. That's basically what. Then you will say whatever type, the type of the value that it returns. Okay. And now we get to main. Okay, main is special because in C and C++, the main subroutine is the entry point of the entire program. Okay, because you cannot have any statements outside of the context of a definition of a subroutine in C and C++. So everything has to be inside a subroutine. But the first subroutine that is being called is main. So that's why main is very special in C and C++, and I believe that is the case in Java as well. So main has a local variable int, so we just say int n, because n is a local variable. And then we say n equals 5, and then we call S2. So remember, in C and C++, when you mention the name of a subroutine and then you start parentheses, it is automatically considered as an invocation. and then we only specify n, it automatically associates n as an argument to the parameter v2 in, as a part of the subroutine S2. So are we okay so far with the syntax? I'm not going to quiz you guys on the syntax here, but do we have any questions about how the C code on the right hand side corresponds to the pseudocode on the left hand side? We good? Okay. All right. So when you get a program like this, okay, I actually need to change the program name a little bit to valval.cpp, because it has to be a C++ program, not just regular C, because of the passing by reference kind of thing. I'll explain that a little bit later. So now we have the C code. We have to compile the C code first. So this is an extra step that you have to perform in order to run a program that is written in C++. So I'm not going to explain this too much. I will just go ahead and finish this process. So it gives you a program called valval, and we can use GDB to debug, okay, quote unquote debug the program called valval. So in a debugger, okay, this is, I'm using the command line version of a debugger, which doesn't look very good, but it gets all the job done, and nonetheless. So what you can do in a debugger is you can stop the program on any particular line and say, right now, tell me what is the value of whatever thing you want to check out. Okay. So we'll put a breakpoint right at the beginning. Okay. So I'll put a breakpoint on line 15, and now we can start to run the program. R is the abbreviation of run. You can spell out the whole thing, RUN, or you can just say R. So now we run the program. We're now hitting the first breakpoint. So this line has not executed yet. Okay, it is about to execute, but I can still ask, what is the value of n? Remember, n is not initialized at this point. Okay, in our trace, it is represented by a question mark, right? But it has to have a particular value, even though we don't know what it is. It has a value. Turns out to be 0 at this point. Okay, but you cannot rely on that. Okay, an uninitialized local variable has an unknown value. It just so happens to be 0 this time.
Why did it say S1 equals 0, not n equals 0?
Huh? It's a $1. The $1 refers to the first print statement. So when you want to refer to the result of a particular print, you can refer to the dollar symbol. So it's easy to kind of like, oh, I need the value that I computed earlier, and you can just refer to the dollar, and then a number, instead of having to spell out the entire expression again. So it's kind of like a shorthand. Okay, so we can single step. Now we can say, what is n again? Well, it's 5 this time, right? Okay, not surprising. So we single step again, and now you can see we're now on line 8, which is inside the subroutine of S2. I know this is hard to read because it's color-coded, but you can see, some of you can see S2 over here. So the program or the debugger knows that we are now in the subroutine of S2, and we're using a value of 5 to specify parameter v2. Is that okay? So now we can single step again, which is computing the square of v2 and put it back into v2. So now we can say, what is v2? It's 25. Okay? Not really surprising. Now we can single step, and this time we are in S1 at this point. So we can single step, and we say, what is v1? v1 is 26. Okay. So now at this point, I will talk about it, but if you don't understand or if you cannot remember, it's okay. I'm not going to test you on these things. But I think it's kind of nice to illustrate, what about v2? What about n? Can we still see what those things are? And if so, how do we do it? Okay. So the first command in GDB that is really useful is called backtrace, BT. Okay, you can spell it out, backtrace, or you can just abbreviate it to BT, and it gives you something like this. Okay, the dark blue stuff is not important, so you can ignore that. It shows you that we are currently in subroutine S1 on line 4. But the question is, how did we get here? Who invoked S1? Then on pound 1, it shows that we got to S1 because S2 called S1 on line 9. Then how do we get to S2? It is because in main on line 16 we called S2. So backtrace is a really helpful tool because because now instead of just knowing where you are in the execution of the program, you can tell how we got there. Is that okay? But in this class, okay, in our traces, we have been tracking things like this from the get-go of this class. Okay, let me show you what I mean by that. So when you go to here, okay, our execution point is basically right here at this point. Okay, so when you look at this particular slice of time, okay, we can ask, how did we get to the subroutine S1? Oh, it's because we made the call on line 8 in S2. How did we get to S2? It is because of line 13 of main. So we can still track things, okay, given the trace that we have been doing, that is parallel to actually what is happening in a C program. You just have to kind of look at it in a certain way, but everything that is really happening in a C++ program, at a machine, on a machine level, we have been keeping track of all of those things in this class. Okay, so when you get to cisp300, it is kind of important to map what you learned in that class to what you have already learned in this class, because there's a close association between the two. Okay, getting back to the debugger, okay? So how can I look at n? Okay, in other words, I am not sure what n is, okay, what is the value of n. So the way you do this is you have to say frame 2, okay? The 2 is coming from this number here, because main is associated with frame number 2. So when you say frame 2, it changes the context of the debugger to the main subroutine. So at that point, you can say, tell me what is n. N is still 5. You can now go to S2, which is in frame 1, and ask, what is V1? Oops, V2. V2 is still 25. Now, how does that correspond to our trace? If you go back to the trace that we are doing, this slice, we're still stuck on this slice of time. Remember, every single row of the trace is a slice of time. So when you look at this particular slice of time, it says n still has a value of 5. It says V2 still has a value of 25, and it says V1 has a value of 26. Is that okay? So the trace that we have been doing in this class actually reflects what is happening in the computer, in the memory of a computer when a C++ program executes. Is that okay? I think that's pretty exciting. It's kind of like getting a little bit of cisp300 for free. Okay, so that's this program. Okay, so let's go ahead and write this program in a different way. So I'm going to change val.cpp to, let's jump all the way to ref. Okay, reference.cpp. So now we look at the C code here. And this is how C++, I should say, this is how C++ says pass by reference. That's it. That's the only change that you make to the program. And now it becomes passing by reference and passing by reference. So it's very concise, okay? C, C++, and Java are very concise programming languages. The mere ampersand in front of the name of a parameter changes the meaning from pass by value to pass by reference. Okay? So now we can do the same trick as before. Let's trace this program in C++ using GDB. Okay, we save the program. We say G++ -G. This is the compiler command. It translates a program written in C++ into the executable so that we can actually run the program. Okay, and then we use a GDB ref. Okay, list the program, and once again, we put a breakpoint on line 15, just like before. So we run the program again, single step, no big deal, okay, single step again. And this time it looks different, doesn't it? Because it says right here, okay, we're in subroutine S2, okay, same thing as last time. But what is V2? It says V2 is at 0x7 blah, 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 okay? That's a hexadecimal number. I'm not going to talk about what a hexadecimal number is, but it is referring to a location in the memory of your computer, okay? And that turns out to be the address of local variable n of main. This is how passing by reference is actually done in C++. Question? Yep. Oh, okay. Okay, it is the address, okay? Now, how do we know it is actually the address of n? Okay, so I'm going to show you another trick here. So I can do bt, okay, backtrace. I set the frame to 1, which means I'm back to the frame of the main subroutine, which has n. So I can always, just print n, which has a value of 5. But I'm more interested in where is n in memory, okay? When we ask the question, where is n in memory, or what is the address of n, in GDB, it is equivalent to which column in our trace has local variable n. Is that okay? So all the columns that we have been allocating, deallocating, referring to, and so on and so forth, they all correspond to memory locations when you execute an actual program. Okay? So the way you ask what is the address of n or where is n is ampersand n. And unfortunately, it prints everything in. Okay, I can read it. You guys cannot because of the projector. It says 0 E. I think it's a 8 E0. Sorry, E0CC, which is the same as this. Okay, so the address of n of main as a local variable is actually represented in V2. V2 says, oh, don't ask me. Refer to this memory location. And that memory location turns out to be the memory location of n itself. Okay, so I'm going to single step quickly through this. Okay, single step, and we're going to add one to V1. Okay, so this is the another really kind of important moment. We ask, what is V1? So it tells us two things, actually. It tells us that V1 has a value of 26, but it lives in this particular location, 7, a bunch of Fs, E0CC. That's the address of where this 26 is. Is that okay? So now you ask, okay, now that we know what V1 is in S1, what about V2 in S2? So now we change the frame, okay, we do a BT, we change the frame to 2, and then we ask the same thing. In V2, we can ask, tell me where is, frame 1, sorry. So frame 1, and then we can now ask, tell me about V1. Oh, V2, sorry, there you go. What do you see? They seem to be the same, aren't they? Because they are both referring to the same location. Okay, so when you look at this, this is at 0, 7 FFF, blah, 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 and then E0CC, that's reference to column C in our trace. And you can see that V2 has the same thing. The value of that particular memory location is 26. What about N? Okay, we change the frame again to 2, and then we ask, what is N? N has a value of 26. Is that okay? So right now in the execution of the C++ program at this particular moment, it corresponds to, okay, let me show you the source code first. This is the code because we are passing by reference and passing by reference. But when you look at the trace, it is corresponding to this moment of time when we trace the program in pseudocode. Is that okay? So what does it mean when we look at this stuff here? V1 is a reference to column C, and that's the E0CC thing. Okay. What about V2? V2 is also a reference to column C, and that's why V2 is also referring to that location in memory that ends with E0CC. Is that okay? Where is that? This is column C. This is the actual memory location that contains the value of 26. It is the local variable n of main, but V2 of S1, S2, and V1 of S1, they can also refer to the same location because we have been passing things by reference. So I'm not sure how much of this is sinking in. If none of this is sinking in, it's okay, because this is the job of your next professor to teach you, about C++ programming. But if you're making some association between the trace that we have been doing in this class and also the GDB session that I have been explaining, even if one little bit is sinking in, that's good because that means I'm helping you to set up for CISP 360. Okay, and we still have about, the clock is correct again. Somebody fixed the clock already, so we got quite a bit of time today. Are there any questions? Is this helpful? I mean, yep.
So what's the usage of the by reference and by value? When do we use in programming?
Okay, very good. So the question is, when do you use by value and when do you use by reference? So whenever you pass a parameter, you have to choose one or the other. Okay? There's no third way of passing a parameter. You can only pass by value or pass by reference. When you pass by value, the subroutine has a copy of whatever you want to pass to the subroutine. It's going to come back, don't worry. But whatever changes the subroutine makes to the parameter stays within the subroutine. That change does not affect whatever you used earlier to pass to the parameter. Okay? That's passing by value. Passing by reference, on the other hand, is passing a way to find some item to a subroutine. Is that okay?
You mean that it's used for searching in the program?
It's useful when you want a subroutine to change something that belongs to the caller of the subroutine. Let me illustrate. Okay, so the program that we have been using is actually illustrating that concept. Okay. In this particular program, we first double and then we add one to, one subroutine is doing the square, the other subroutine is just adding one, right? But you can see the effect, okay? The doubling and also the adding one is affecting something that belongs to main. This is why you need to pass by reference, because if the intention of the subroutine is to do some calculation or do some kind of processing, and you want that processing to be done to something that main owns in this case, then you have to pass it by reference, because there's no other way for the subroutine to find out, oh, where is that place that you want me to update? You have to pass it by reference so that the subroutines, in this case S2 and S1, also know where in memory or which column they need to update. Okay? On the other hand, if you just want to determine something, okay, you just want to, okay, let me give you another example. Okay, so this is another subroutine here. This one is really easy. Define, and this is plus. And we just want to calculate the sum of two things, okay? By val x, by val y, return x plus y, and define sub, okay? This is define sub plus, there we go. So in this case, you do not need to pass x and y by reference because we are not intending to change x or y. We just need to know, oh, which two values do you want me to add? But what about the sum? You have to get the sum back to the caller because otherwise it's meaningless, right? So this is a very typical way to use a return statement so that the invocation of the subroutine itself can go to a place where a numerical value is expected. Is that okay? Okay. So does that answer the question of when do we use pass by value and when we use pass by reference? It's good. Okay. What about the rest of the class? Are there any questions about this? No. Okay. Does anyone want to know what this kind of program looks like in C++? Yep. Okay. We got one. Only one person is interested. What?
You're talking about that code?
Yeah. I'll finish the rest of the code because right now it doesn't do anything. I mean, you can have a program that only defines a subroutine, but it won't work, right? There's nothing to trigger its execution. So we'll go ahead and say define main, define sub main, local variable n again, and this time gets the result of invoking plus. And this time we can just pass numerical values, like 45 is used to specify x, and 78 is used to specify y, and define sub, invoke main. Okay, so this makes the program a little bit more meaningful because we are actually doing some computation. Okay, actually I'm not gonna, well, I may trace this in pseudocode, but the first thing I'm gonna do is to write this in C++, so that this way you have an idea of what it looks like in C++. Okay. We'll call this plus.cpp. So we have a subroutine called plus. So this time, instead of using void, we say int. So the type of the value that you're returning, in this case, because we are returning x plus y, assuming x is an integer and y is an integer, the sum is also going to be an integer. So we specify the return type of a subroutine first, and then the name of the subroutine, and then we specify the parameters. So in this case, we have two parameters. X is one and y is the other one. Both are integers. And guess what? The only thing we do is return x plus y. So that's how we write the actual C++ code corresponding to that pseudocode. Then we get to main. And in main, we have int n as a local variable. And then we say n gets plus 45 and 78. So this is what I want to illustrate. This is also what I was talking about earlier, is in C++, in C, in Java, JavaScript, and many programming languages, everything is done by position. So 45 is the first thing in the list of arguments. It simply goes to the first parameter of the definition of the subroutine. The second one goes to the second one, and so on. Okay? It's good in many ways because you have a whole lot less typing, right? So instead of doing the right arrow thing and then naming the parameter that is supposed to receive that particular value, you just specify the values. But the downside of this is if you cannot remember the ordering of the parameters and you make a mistake, nobody can actually warn you and say that, oh, I think you meant this and not that. Okay? So it is good and bad. It's mostly good because your program is a whole lot shorter. Are we doing okay so far with this? Yes? Okay. So I can trace this code through in GDB, which is going to start with this part here. It will go here. You will see x is 45, y is 78. And then when the return statement happens, and then we will go back. It will actually combine the return statement at the end of the subroutine into one single thing. Then we'll go back to here, and then n is going to be updated to 45 plus 78, which is 123. Is that okay? So the stuff that we have been talking about is actually, going to do the same thing over here. Does anyone want me to trace this, in pseudocode? Yes? Okay. All right, so to trace this in pseudocode, we got line number. Precondition has nothing to say because once again, we do not have any global variables. On line 10, we invoke main. So we have a return line number and also local variable n starting with an unknown value. Return line number is going to be post so that when we are done, there's nothing else to do. in main on line 8, the first thing we need to do is to say, well, we would love to update local variable n, except I don't know what the right-hand side of the assignment is. So I need to do the invocation. So when we do the invocation, this time we need return info and not return line number, because the subroutine plus has a return value, and the return value is utilized on line 8 to do something else. So return info has to say we need to go back to line 8 when the subroutine is done, because on line 8 we still have the assignment operation that is yet to be done. But every time you invoke plus, you have to supply the two parameters. One is x and one is y. They're both passed by value. So 45 simply goes here, and then 78 simply goes here. Do we have any questions about how we set up all the columns up to this point? Nope. Okay. So now we continue execution in the subroutine on line 4. Line 4 says return x plus y. Well, I know what x is, 45. We know what y is, it is 78. So we can compute the sum, which is 123. So we are basically just saying return a value of 123. So we locate the return info cell, we copy and paste it, and then we change the question mark to 123. Then we move on to line 5. Line 5 says, well, this is the end of the subroutine. Let's go back to whatever was invoking this particular subroutine. Okay, how do I know where to go back to? Return info. So return info goes back here. And then we say, now we have no use of these 3 columns. And then we paste it here. Oh, okay. My bad. So copy, paste. I think my keyboard is not responding very well. The control and the control key doesn't seem to be working very well. Okay, so now we get back to line 8. So when we do get back to line 8, we already know what the right-hand side is, and now we can do the actual update. N is now updated to 123. Then we move on to line 9. Line 9 is n defined sub. So we look up these 2 columns. We say deallocate these, but remember that we're supposed to go to post first. And then we mark these as deallocated, and we're done. So are we doing okay so far with this? We're still okay? All right, excellent. So I'm all pretty much done for the topics of today. Once again, the C++ example is not in the scope of this class. Okay, but if you do, okay, even if you don't remember anything today, okay, one thing you can do is to jot down on a piece of paper and say that on November 21st, almost at the end of the lecture, Tech talked about passing by reference, how to use GDB in C++. So when you do take cisp300, when they start to talk about passing by reference, then you can refer back to today's lecture on YouTube. So maybe at that point you'll go like, oh, right, now it's making sense, okay? Because I'm starting to understand the syntax of C++ and know other things about C++. Then it starts to make sense, okay? So you can do that if you want to. When we come back next Thursday is a holiday. So when we come back on next Thursday, I just want to point out what we'll be talking about. I'm going to add more notes too. We'll be talking about mixing arrays and parameters. How do we pass arrays as parameters? And what do we do when we have a parameter that is an array that is passed? Okay, so that's what we'll do on Tuesday when we come back. And so the lecture is done. You guys can leave like 5 minutes early. And I am going to send the spreadsheet to all of you right now so I don't forget.
Are you teaching the class of 360?
I'm not teaching 360. No.
So
Well, they're all pretty good here.
Like the one who submit the videos is like as really useful, helpful the videos.
Hmm?
Like the one who also add the videos on YouTube. The videos.
The
The
schedule?
teacher, no, the teacher who
Uh-huh.
add videos like in the YouTube, like it's really
So,
useful.
so you can look it up. Let me finish this first. Okay. So spreadsheet of today. See attached, and
Because I think every teacher is not adding videos on YouTube. He's just teaching and that's it.
I don't think anyone else is using YouTube.
There's no one else.
I don't think anyone else is using YouTube.
We don't have any homework for this week, right?
Yes, we do. I just assigned it today.
Oh, you did?
Yep. So, but you have until the Tuesday after the break to turn it.
Oh.
Yeah, because I cannot make it due on the holiday. Yeah. So